Jai Shri Ram to everyone. I am Samprita Kulkarni from Sri Venkateshwara College of Engineering, Bengaluru. Today we are going to learn topological sort. Topological sort. Topological sort is an algorithm to sort nodes in a directed acyclic graph, which is also known as DAG, in a specific order where each node comes before all its successors. Come with us on a journey to learn more about it. We are discussing here two methods of topological sorting. First one is topological sort based on DFS and other one is topological sort based on decrease and conquer method. Topological sort based on DFS method. There are two steps. First, you should apply the DFS algorithm to the each node to traverse the nodes. Perform DFS for traversal and note the order in which vertices became dead ends. You should traverse the nodes until it became dead end and reverse this order to get a solution for the topological sorting. Of course, no back edge has been encountered during the traversal. If a back edge has encountered, the digraph is not a DAG and topological sorting of its vertices is not possible. To illustrate the DFS algorithm in topological sort, we will see the example. Here, this is the problem. This is the figure 1, figure 2, figure 3. First figure tells us diagram for which the topological sorting problem needs to be solved. Then second figure tells us DFS traversal stack with the subscript numbers indicating the popping of order. And third one is the solution for this problem. First, we will start from the C2, then we will move towards the C3. We will traverse from C3 to C5 and C5 is the dead end. We will traverse back to the C3, then we will go to the C4. Then no need to go from C4 to C5 because C5 is already visited, so that we will come back to the C3. Then C3 is a dead end now. Then we traverse back to the C2. Then C2 is also dead end now. Then traverse the C1. This is the traversing order of the particular problem. This is the dead ends which are pushed in the stack, uh, so that the popping order of the problem is C5, C4, C3, C1 and C2. The topologically sorted list is from C2 to C3. We have visited like that only. C2 to C3, then C3 to C5, then C3 to C5, and no need to uh, visit C5 to C4, like we don't have arrow marks there, so that we traverse back to the C3, then C3 to C4. So C3 to C4 we visited, then C1 we have visited. This is the required solution for this problem. I hope you will understand. Now we will discuss the second method, that is topological sorting using decrease and conquer method. The algorithm is based on a direct implementation of decrease by one, means we have to decrease one single node we have to decrease, and conquer method. Repeatedly identify in a remaining digraph a source which is a vertex with no edges, no incoming edges, and delete it along with all edges outgoing from it. If there are several sources, break the tie arbitrarily. If there are none, stop because the problem cannot be solved. The order in which the vertices are deleted yields a solution to the topological sorting problem. To illustrate that, we have an example here. Illustration of source removal algorithm for the topological sorting problem is given here. On each iteration, a vertex with no incoming edges is deleted from the digraph. Digraph is nothing but directed graph, means direction is given in the graph. This is the problem. Here we have two nodes with no incoming edges. We can delete any one. We should delete only one node which is having having no incoming edges. This is possibility of nodes are two here, but we have to delete only one node. We are deleting here C1 in first iteration, then the digraph becomes like this. Then C2 is the node now, so we have to delete C2. Then the digraph becomes like this. Then the C3 is the C3 is the node now, which is having no incoming edges. So we have to delete C3. Then the graph becomes like this. No incoming edges for C4. Then we have to delete C4 and C5, which is having no incoming edges, so that you can delete C5. This is the order of deleting the edges which is having no incoming edges. Then the solution is C1, C2, C3, C4, C5. The solution obtained by the source removal algorithm is different from one obtained by DFS based algorithm. Both of them are correct only, of course. The topological sorting problem may have several alternative solutions. These are the simply two solutions based on DFS and decrease and conquer method. Now it's time to discuss application of topological sorting. We have many applications, but here we are discussing some of them. Instruction scheduling in programming compilation, we have topological sorting application, and cell evaluation ordering in spreadsheets formulas, we have the application of topological sorting there also, and resolving symbol dependencies in linkers. So many applications are there, some of them are listed here. I hope you understood the concept. Thank you.